Welcome, everyone. My name is Ryan Reese. I run Mission's data analytics and machine learning practice, where we work with customers every day where they are in their data stack. I'll give a real brief, infomercial for Mission in a few seconds, but I'll make it short. Most of this presentation is all about the content. I have with me today one of our data architect, Scott Clark. He's been working in the AWS space for over 10 years. He knows tons and tons about Redshift as well as anything in that data space. So looking forward to the content that he's put together to share with you all.
Well, thank you very much, Ryan. And again, Scott Clark, the title is Big Data Consultant here at Mission. And just a little bit about my role. My job is to work with customers to gain insight into their data, understand and help build out their requirements, and then take the two of those and match those within the AWS ecosystem to services and third-party ISVs as well. And this all takes place through the implementation of several frameworks and methodologies, chief among them, a modern data ops framework, the working backwards, which AWS has refined that process, and we work with that as well. And also we design and build in the lens of AWS's well-architected review service.
Great, thanks, Scott. So what's up for today? Like I said, I'm going to give the 30-second infomercial of Mission. Then we're going to spend some time just talking about Redshift versus Snowflake. I know that's been on a lot of people's mind. Then we'll talk about the data analytics landscape, why customers are really choosing Amazon Redshift. Scott's going to deep dive into the architecture, talk about data warehouse migration processes and journey, and how to prepare and plan for your data warehouse migration. And then if we have time, he'll talk about the migration toolkit, many of the tools that are out there that can help you accelerate that data warehouse migration. And as I mentioned, feel free to put questions in. We'll be monitoring them as we go. And if they, we'll try to be answering them either during the presentation or at the end, depending upon complexity. So who is Mission Cloud? We're an AWS premier consulting partner. We've worked in the AWS ecosystem for a significant number of years. We have, many of the competencies, migrations, DevOps, Microsoft workloads, Redshift delivery competency, many verticals, healthcare, life sciences, and many other companies. Oops, I guess that slide isn't there. So, anywhere you guys are on your data stack, Mission can help you guys along your journey. We work exclusively in AWS because we believe in the concept of mastery, and since there's over 400 services now, in order to really look at all of those services and understand them and be able to deep dive into those to figure out how to join them all together, we're focused only on AWS as a customer. So what's the data analytics workspace look like these days? I'm sure many of you guys have been in the space for a long time. Back in the late 1980s and into the 90s, you had big warehouses that were being built on-prem, right? You had large data marts for each of your different divisions. You had BI reports and all that was going on, right? And your ETL jobs, pulling data, mostly on-prem, because there weren't a lot of external data sources at that time. Then in 2011, when the cloud really started to take off and you're starting to see more data lakes built out, they basically really kind of replicated the same infrastructure they had on-prem into the cloud. You had a very similar kind of ETL system, right? Data would land or be pulled into your data marts. Your reports would be put together. And sometimes you would have data, if it was unstructured data sitting on the data lake for your machine learning aspects and your data prep. But really, this was still a pretty warehouse siloed kind of system. And in the last year or two, the concept of a lake house has really appeared. And the lake house is more trying to figure out a layer, you know, that's sitting there on top of everything to really help you do more streaming analytics, right? Really do data science on the fly and get your BI reports coming in real time. So that's kind of been that push into the Lakehouse architecture. If you're not, you know, you still see a lot of data marts and all that coming off of the Lakehouse itself to feed, you know, reports and BI, but you also are seeing a lot more real-time BI that's going on these days. So these traditional architectures, you know, had, you know, what people are now starting to call dark data, right? Where you would end up with collecting a ton of data, it's sitting in your data warehouse, and you just don't even know what to do with it, right? You don't know how to extract insights from it. You don't know how to handle it. It's scaling massively, right? You're collecting data from all of these sensors and it's just sitting there. You don't have enough time. You don't have enough people to look at it, right? You don't even know what the use cases are for it. And that led to a lot of high costs, right? You had administrative overhead where you just had machines, right? You have all this data. I'm sure you guys have looked at where do you cut costs on your AWS account, and you look and see, you know, your S3 bill goes up every month. How do you figure out, you know, what we call now data governance strategies, right? When do I roll this into Glacier so that I can save costs on my storage, yet keep all that historic data in case I want to go to it? And, you know, you also want to look at it and say, okay, what's the value in this data, right? What am I going to do with it? Am I ever going to use it? If I am, you know, do I want to keep it hot or should I put it into that deep storage? And the other problem with a lot of the older legacy, like I said, it came from the data warehouses that were on-prem, and they just kind of felt, you know, you do the same thing in the cloud, one size fits all, and that just didn't necessarily work. You saw a lot of companies really push into more and more data silos, which caused problems because when you're looking at doing machine learning and things like that, you want to have all that data. I've worked on several projects where it took weeks to get access to other parts of the business's data that I needed for my model, simply because you had to go through all these processes at, you know, large companies to prove that you needed that data, right? And sometimes it might have PII in it, and you really had to justify everything. So you can really slow down your data science, your reports and all that if you're not really thinking about your whole architecture as a whole and looking at, you know, using all the new tools that can really allow you to democratize your data. So that's, you know, really what Redshift is great at, and, you know, you'll see some of that in Scott's talk coming up. I'm sure you guys have heard all kinds of sayings out there, right? Data's the new oil. The world's most valuable resource is no longer oil, but data, right? I think the really big piece that I look at is more data is created every hour today than basically an entire year 20 years ago. You know, when you think about it, you know, the amount of sensors that people have, even IoT devices, right? People don't think about phones and all those as IoT devices, but they're collecting tons of data every minute. If you're working in warehouses, there's all kinds of systems out there now sending back data. And so you're just getting clobbered with this data and need to have a good strategy of how are you going to handle it. So Amazon's big data warehouse is Amazon Redshift, and it has a corollary Redshift Spectrum as well that you can use to query data on the cluster. You know, basically with Redshift, you know, you can analyze all your data. It has massive performance at scale, right? It was built to really house large amount of data, and it can lower your costs. One of the great things about Amazon Redshift, if you know how you're going to use it, you can buy RIs, right, reserved instances, which will drastically decrease your cost. And I'll talk a little bit about that in a few minutes. Here's just a big customer sample list that AWS has for people on Redshift today, right? I mean, people are using this petabytes, exabytes. I mean, it's just massive in all of the enterprise and smaller businesses. And, you know, it's really one of the data warehouses of choice that many companies use today. So how do you use Redshift in your data architecture? So I'm sure you guys have seen a lot of Data infrastructure, this is kind of our lakehouse infrastructure that we start with customers. As Scott was mentioning, when we work with customers, we always work backwards, right? So we usually start here on the right-hand side. What's the outcome that people want, right? Is it going to be they're looking for visualization and reporting, or are they, backing applications or mobile apps, or is it just users like data scientists? So how are you going to go about enabling those customers, and what are their personas? And so we look at Redshift, as one of those data warehouses, data marts. It's great to feed all your visualizations. Data scientists love it, right? RDBMS, super easy to query your database with SQL, pull out information in your historic loads. And then you look at, okay, if I've got Redshift, I'm going to have to move data in it through ETL. And, I myself always like to keep my raw data. So you've got your data lake storage, right? You're going to be pulling in data from that left side from your data sources, doing ingestion, putting data into your raw zone. And that's where you're going to talk about governance strategies, right? When do I roll my raw into my archive? What kind of transformations am I going to do to my data when it comes in before I load it into Redshift as well, right? There's usually a transform zone or multiple transform zones that we see with customers. So this just kind of gives you an idea of that lakehouse architecture and, going to Redshift. So during that migration phase, right, one of the big things that you have to look at is, yeah, I've got all this data, I'm going to pull it into the cloud, I'm going to move it over often through DMS into Redshift if it's on a SQL store. And then I'm going to have to reconnect all of my outside sources or bring in new sources that are going to go through this process and feed Redshift, so you can continue to add additional data into your cluster and just, new data. There's all kinds of APIs out there that you could be using. There's all kinds of data sources out there that are really cool that you can just, bring in and enrich your data and help your data scientists with new models. So in that space with data marts, data warehouses, this has been a pretty crowded space. There's new entrants coming in all the time, right? We're going to focus at this part just on Redshift and Snowflake, but people I'm sure have used Teradata, Qubole, Fireball, Microsoft SQL Server. We're not really going to touch on Databricks. Databricks to me is more of a kind of an EMR tool, kind of fits in the glue upsolver kind of realm. And so, it's really interesting. I keep waiting for the space to kind of change and people be bought up, but right now it's still, everyone's coming out with something new, something vertical specific. So, I'd really watch out as a company to look at some of these new products that are out there. They may seem perfect, but perfect for your exact use case, but is that really the system you want to use, or would you prefer, tried and true, this is gonna work for you? It might not have all the specific vertical things you're looking for, but it's going to be better in the long run for you. So what's a definition of a data warehouse, data mart? So data marts, right, usually focus single subject. They're often for functional organizations. You usually have few sources in those. They're not very big. You've normalized the data. You've kind of pushed it. Sometimes people use Redshift and push in particular views that they kind of consider data marts. A data warehouse is more, that focused whole enterprise repository that has, many external sources coming in. You've really that's where all of your data is going. So you can think of a data mart as kind of a subset of a data warehouse for a specific department. So what are some of the big things about Redshift and Snowflake? In honesty, there's a lot more similarities between the two than there are differences, right? Both are relational databases, both you use SQL to pull everything out. They're both massive parallel processing architectures, right? They're managed services, often utilized for just BI or machine learning. Although Redshift is a little friendlier, especially with Redshift ML that's come out. You get ACID compliance. Both have a lot of security. They have integrations with most of the tooling that's out there. You can do column level sharing between them both. And you can scale up and down your clusters, right? The new RA3 nodes, and we'll talk a little bit about that as well. And there's a lot of companies that have been out there and have shown that basically the querying times are the same and the cost per query is the same. So there's really no difference as you're querying your data between these two systems. So what are some of the Snowflake selling points, right? They really push on this from a marketing standpoint, that they separate compute from storage. This basically is just a slightly different way than how Redshift scales, but with the new RA3 nodes, that's pretty similar. The biggest piece that people like is the pause and resume functionality in Snowflake. And with Redshift, you have that, except you need to come back and you basically set that as a time versus just it automatically does it in Snowflake. And then Snowflake, what people really like is that it's an intuitive, you have more intuitive web browser based interface. Seem to have stalled on camera. And then finally, Snowflake has a little bit better JSON support and other semi-structured data types. So what are some of the common Snowflake complaints, right? If you're running your business and you're using on-premise technologies, they really don't talk together very well, right? They're really just not the right option if you're on-prem. It was really built to be in the cloud. You got to really watch out as you're using your Snowflake credits. Every time you start a virtual warehouse, you start getting charged at a minute's pace. So, really look at how your queries are running and planning all of that out. Snowflake SQL editor, people complain about it quite a bit, that it doesn't have autocomplete. It's a little more finicky. And then Snowflake is often expensive, right? If you're not using the right use case, you're really paying for it at the end of the day. So what are some of Redshift's selling points, right? It integrates closely with the whole AWS ecosystem. There's great things about the Redshift federated query. It lets you pull data from basically any of the other databases as well, right? If you have RDS tables, if you have Aurora tables, if you're using Redshift Spectrum, right, you can use the Redshift federated query and bring that all out and into, whatever application or things like that you're using. Redshift Spectrum really lets you extend Redshift, searching across the data lake. It gives you a lot of support for unstructured data, for JSON files and all that. Redshift, will coexist with on-premise infrastructure, as we were talking about. DMS, you can be pulling back and forth with your on-prem through DMS, so that's a great feature. Redshift's been longstanding in the industry, right? You can get up to 8 petabytes of compressed storage if you're looking for that in each data warehouse. And AWS is constantly adding new features. The ML piece, I forget if I have a slide, but that's really fascinating, where they'll use your compute nodes inside your Redshift cluster to do the inference on your tables inside. You also have the new RA3 architecture, which really lets you do that, scaling your compute separate from storage, which really puts it on par with Snowflake. And as I mentioned at the beginning, you get a lot of cost savings if you go with reserved instances. Some complaints, right? It's not really a transactional system, which you usually use Aurora Dynamo for. Sometimes if you look at Amazon Spectrum and you don't set your partitioning right, you're charged extra based on the byte scan. So you really want to make sure you have a good partitioning scheme when you're using Redshift Spectrum. One of the other complaints, right, Redshift is still, it was split off of PostgreSQL 8. And so it doesn't have all the new features and some of the newer SQL versions. So you do have to keep that in mind. And, that's, you've got a few things with integrity of transform tables, but those are constraints that aren't necessarily enforced, that you just need to watch out for. So let's talk a little bit about the advantages and disadvantages of the different areas, right? Separation of storage and compute. You can independently scale compute and storage for, that's basically what Snowflake was built off of. And you can turn off all your computing resources. The disadvantage, though, is if you do heavy compute and your people are running jobs all the time, then Snowflake's just going to get really pricey. And as I mentioned, Redshift closed that gap with the RA3 nodes, which basically gives you the same functionality. Snowflake likes to sell that they're multi-cloud, so don't get locked into a particular cloud provider. But my argument for that is you may not be locking into a cloud provider, but you're still locking into a technology solution, right? Snowflake still has its intricacies, it has basically created its own tools, right? And Snowpipe, SnowSQL, Snowpark. So you're learning languages there as well. So you're really sure you're multi-cloud, but how many companies are really going to a multi-cloud strategy? Because there's so many services. We see a lot of companies are just sticking to one cloud, so it's not really a selling point. And you just have to realize, hey, what technology is going to be the best for my solution? JSON semi-structured support, right? Snowflake was built on this. It does do a better job. Redshift's closed the gap. They came out with a new type super. They have PartyQL, which is a query language that you can use to process the semi-structured data. You can use, Redshift Spectrum for a lot of JSONs. So, there are a lot of advancements. Redshift's constantly changing and improving this. But, Snowflake does have, advantages in this area. Maintenance, yeah, I know Snowflake loves to say there's no maintenance. That's just not true. You still need to support the system. It does have a really good setup though, but just take that with a grain of salt that you are going to have to always be watching your cluster and maintaining it, maintaining your job, checking for quality. Redshift's been doing a lot of work in this area, right? They've got auto vacuuming, auto WLMQ. One of the really cool new features that I've seen is, they're looking at what jobs you're running, and they'll use ML to try to improve how those jobs are running and decrease the query time. So that's something pretty interesting to look at as well. Security, both of them have all of the security that you want, right? All the bells and whistles. The only difference is you need to understand for the security you want, which of the 7 pricing tiers in Snowflake has those bells and whistles. So, there can be cost implications on the security side. Pricing, right? Redshift, pretty straightforward. How many hours did you run? What's your cluster size? And that's basically your cost. Snowflake, is complicated, right? You've got this tiering structure. So sometimes it's less expensive, sometimes it's going to be more expensive. So you just have to be really careful as you're looking at this on the Snowflake pricing side. And as I said, right, you get some RIs, you can see, significant price savings when you're using RIs versus on-demand pricing with Redshift. And you'll see often that, you can get almost a factor of, 2, 3, 4 on your on the cost of your data lake over Snowflake if you're using RI, like a 3-year RI. So that's something to take into account as you're looking at your warehouse. This is really, user interface is the biggest driver, right? Snowflake definitely has the friendlier user interface. That's one of their big selling points. AWS has been improving the Redshift interface, but it's still just not quite the same as Snowflake at this time. One thing for us as partners, Snowflake doesn't really care about its partners, right? So what we see them do, they'll come in, work with a customer, set up a POC, and then just kind of leave them to fend for themselves. We've got Snowflake developers here at Mission. So if you've tried to go to Snowflake having some issues and need support in that, we're happy to work with you on the Snowflake side as well. So what are some of the optimal Snowflake use cases, right? Basically, are you an organization with a low query load where you can frequently scale down and, pause and resume what you're working on? So that's really where you're going to find the best value with Snowflake. Some optimal Redshift cases, obviously, as we were talking about, if you have massive workloads that are going on that can range from millions to billions of rows, then Redshift's really going to be the winner in this case. If you've got an entire AWS ecosystem where you're pushing a lot of data back and forth across all the different AWS services, Redshift just integrates into that environment a lot better. And so you're going to want to look at that solution with Redshift. And then if you know that you're going to have your cluster for a long time, then getting those RIs can be a huge cost saver for you. So here's just a quick, list of the comparisons between the two. I'm not really going to go through this. Obviously we just did. So if you see the recording later, obviously you can stop on this slide if you're interested. So finally, on this section, sorry, as a company at Mission, we look to talk to our customers. We offer a free hour-long consultation where you can get in touch. We'll sit down with you guys, try to understand your architecture, give you some advice, just work with you guys on what you're trying to do in AWS and point you in the right direction. Or, if you're looking to really work with a partner, we can, use that session to kind of walk through MVPs or just what AWS can do for you and how Mission can help you. So finally, I see there's some questions, so I'll answer those questions real quick before we turn it over to Scott. So how would I compare a lakehouse to a distributed data mesh? So in my mind, I feel that those are pretty similar, but Scott, did you want to try to tackle?
Yeah, I believe I answered it in the chat. I just didn't see it pop up. Yeah, it really depends on the use case. And for example, if you're a multinational company and you, for compliance reasons, have to, maintain data in a certain geographic region, a mesh architecture is really going to work for you. And it doesn't have to be a international company if it sort of fits that mode, whether it's very departmentalized businesses or regionally. Sharing that data keeps it from, it's very secure. You can secure it very fine grained, and then you don't have to move that data around. So, that's really the use case for the mesh. The hub and spoke is certainly a great place to get started, and it doesn't dictate that you can't go to mesh down the road. So hope that answers the question.
Cool. Yeah, it looked like it was just the same question, but go to webinars acting up. Does anyone else have any questions on the Redshift kind of Snowflake piece? Okay, so Scott's going to walk through a deck on much more on migrating into AWS and the rest of the points we had on our agenda.
I'm sorry, Ryan. It's always something here. I want to. It's asking for permission, so give me just 1 second. And there it is. Be right back. Here he goes.
Scott, if you need me to share, I can share the deck.
No, I believe I'm good now. I just, had to set a preference, security preference. So, share screen. Did you pass me control?
Yeah, you should have control.
Okay. Okay. Everybody see the screen? Can you hear me okay?
Yeah, you're good.
Great. So thank you, Ryan, and apologize for that little glitch. So why are customers choosing Redshift in record numbers and making it the most widely adopted data warehouse in the cloud? And that's what we hope to answer here in this next section, where we want to walk through some of the key features and services and recent updates to Redshift, take a high-level look at the architecture, look at the migration process and journey, and then also some of the AWS tools that help manage that migration. Okay, so challenges with managing and data analytics at scale. You know, obviously, as Ryan had mentioned earlier, the explosion of data from new sources, the volume of it, new sources, new data types, and all that needs to be, you know, all that needs to be analyzed and addressed with new analytic solutions and architectures. In many cases, you know, the current architecture or challenge is that you have to move data around a lot, and that's not good because it's prone to error. It's, you know, it's less secure, and, you know, and there are costs associated. So, you know, in other words, the current legacy architectures are siloed. Again, as Ryan mentioned, less performant and cost an arm and a leg. You know, the time to value to gain insights into your data is never negatively impacted under this current, you know, architectural or design schema. You can also think about, you know, in the traditional architecture, the time it plans to, you know, to upgrade capacity, to install that capacity, you know, and get it up and running, and then you've got the network capacity issues that go along with that. So these solutions really don't scale well. They're hard to govern, and, you know, it can be kind of a nightmare to manage from a security standpoint. So all that, what does that mean in the end? You know, bad user experience, missed LAs, and upset customers. So given all this, you know, customers are looking to adopt a new architecture, you know, sometimes referred to as the lake house architecture or the data lake, you know, architecture. So with the lakehouse architecture, you know, sometimes also referred to as a modern data lake analytics platform. In the case of AWS and Mission, it all starts with S3. You know, customers have been building data lakes on S3 for years, and there are more data lakes on S3 than any other place in the cloud. And why is this so? Because it's giving you so many options, you know, to both query and analyze your data. You know, for example, in the lakehouse architecture, you can use Athena to provide ad hoc queries and views to downstream visualization tools like QuickSight or Tableau or, you know, Power BI. You know, also you can access, you know, your relational data stores and your NoSQL data stores, Aurora, Dynamo, also OpenSearch and EMR. But certainly Redshift is, you know, Redshift is a key player in all of that for sure. But in other words, you can pick the right tool for the right job in this infrastructure. At the center of the whole thing is AWS Glue, and AWS Glue helps you from to have to move data around. You know, you can run your ETL processes, pretty beefy ETL processes on on Glue, and then as well, it's providing a Hive compatible metastore, which is accessible from all, you know, from all your different query engines, obviously based on fine-grained controls. And then to sort of manage all of this, you have AWS Lake Formation, and you can think of AWS Lake Formation as a wrapper. It's got the security, fine-grained access, you know, database, the obvious ones, database, table, and then column and row, but it can also go as fine as, you know, cell level or you know, cell level security. And so yeah, it just really acts as an intelligent way to manage all that, and you can manage your Glue jobs from in there, and your meta catalog. And then this fine-grained access is also being propagated, throughout this entire, architecture ecosystem, if you will. So analyze all your data. Essentially what I just said a few minutes ago, but let's look at some finer points. Redshift is fully integrated with the lakehouse architecture and lake formation, as well as data stores like Aurora, and touched on that. You can also, and this is a relatively new feature, is you can perform real-time analytics. I'm sorry, I jumped ahead of myself. With Redshift, you can now run, train, and deploy ML models at scale with simple SQL statements, and we'll dive a little deeper into that later. It's unique in the fact that you don't have to load all your data. Like a lot of warehouses, technologies, you need to load all your data into the warehouse, and obviously that increases storage and size and cost. With Redshift and this architecture, that's not the case. So you can go from querying gigabytes to exabytes of your open file formats like Parquet, JSON, ORC, CBS, CSV, etc. You can perform joins across all these data stores, including Redshift Spectrum, which Ryan mentioned earlier, and we'll touch on that a little bit later. You've got federated queries that you can initiate, again, down to your other data stores, RDS, SQL Server, MySQL, Oracle. You're getting faster performance at scale, 3 times price performance versus the competitors, and 10x performance at 1/10 the cost from on-prem data warehouses. So you can see that the pace of innovation here with AWS and the Redshift is incredible. There have been about 200, approximately 200, and it probably changed today, new services introduced in the past 18 months. So just as Ryan was touching on some things earlier, that some of that is now a little bit out of date because they launched in GA or in preview with a lot of new services here. And so we want to touch on, super data types such as JSON, are now ingestible into your Redshift. The Lambda UDF is really cool in the sense that, you can build your UDF, user-defined functions, and within Lambda, and have Lambda execute those. So that Lambda is a serverless architecture, and you're not paying for compute that you're not using, simply put. Again, pause and resume is now, as Ryan mentioned. Spectrum, you can take your data, and that's always a subjective comment in terms of what's hot and what's not, what's warm and what's cold. But with Spectrum, you're now able to query that data as it sits in your data lake within the Spectrum, architecture of your data lake. You have materialized views with automatic updates of those materialized views, and there's a lot of other ones, and we're going to get into them here shortly, in a little bit more depth. So as Ryan mentioned earlier, the RA3 instances, I really come to have a great appreciation for this this particular node type. So what it's doing is it's allowing you to size compute and storage separately, simply put. And underneath the hood, you have AWS's proprietary Nitro system, which is using high bandwidth, high network bandwidth, and some very fast SSD cache, making the overall solution very fast. So these also additionally, the advanced data management technique that is running under the hood, allows your data to grow, and for Redshift to automatically move that data to managed storage, which is essentially, again, S3, and you're paying S3 cost for that data, and it's scaling automatically. So just really interesting and great stuff we're seeing with that. You've got some of your node types are your RA4 or X plus, RA3 X4 X large, and 3 RA3 16 X large, and those range from 4 vCPUs and 1024 terabytes of managed storage up to 49 vCPUs and 16 terabytes of managed storage. Another really cool recent release here is Aqua, which is essentially a hardware accelerator, and what it's doing is it's bringing the compute closer to the storage. So you're seeing about a 10x factor over other cloud providers' solutions. It scales automatically, and it's pretty cool that it's at no additional cost if you're using the RA3 node type. Okay. And the hits keep coming. Data sharing, another fairly recent announcement, and very interesting for the right use case. There was a question about meshed architecture as part of the data lake architecture. This is a meshed architecture at the cluster level. So it's instant, granular, low latency access without having to move your data, and it allows you to secure and govern it across the organization and external partners. And think back to the fact that we've got lake formation and its fine-grained access integrating with Redshift and its fine-grained access. And I don't mean to indicate that the two are separate. They're very much, interconnected. So, all of this is going to let you isolate your workloads and, again, keep the data from moving back and forth. But you can share it with, external partners, divisions, departments, however the natural, fallout of how all this plays out within the organization. And the subject that a lot of people are interested in today, is machine learning. But with Redshift ML, it's made about as straightforward and cost-effective as you could possibly get, in my opinion. So what you're doing is you're creating, you're training, and you're deploying models all with simple SQL statements from within Redshift. And so what's happening under the hood is Redshift ML is making a call to SageMaker, which, for those of you who are not familiar with that, is AWS's managed service for building, training, and deploying machine learning models at scale. With built-in, with quite a few and popular built-in algorithms, along with you can bring your own algorithm. So it trains a model. It's supervised or partially supervised is how it's described. But anyone that's worked with or looked closely at doing machine learning has understands and clearly understands that the 80–90% of the cost is in the inference. And with ML, Redshift ML, Redshift is deploying your inference, so there's no cost for inference. And I just find that fascinating. So in other words, you're paying for training and modeling, but not the inference. So that sort of brings me to the conclusion of looking through some of the key features and architectures and so forth. There are a number of other ones we'll briefly touch on as we continue through the deck, but like concurrency scaling, and concurrency scaling, allows you to automatically scale your workloads on demand. There's no pre-warming. Excuse me. It's hot and ready to go. And the nice feature of that is for every hour that your cluster is operational, you receive 24 hours of burstable concurrency scaling for free. So, essentially in a month, you could get about 30 hours of, if you're running 24/7, 34, 33 hours a month, something like that. Another one, from a reliability, resilience standpoint, is cross AC cluster recovery. And it's a 0 RPO data loss and on demand failover. So recently added and a great addition as well. So let's kind of go back and put that all that, try to digest it into one digestible slide. Redshift is a managed service, and most of the administration for it can be handled automatically. So that the Redshift is continuously monitoring your cluster, looking at your data, looking at your workload, and trying to improve the physical layout of that data on the cluster, and that's automatic. There's self-tuning aids with table design optimization, several options to resize the cluster, classic and elastic resize. There's some trade-offs on each one of those, but essentially elastic is faster and classic gives you more options in terms of node sizes. It can automatically select your sort keys and distribution keys. With Workload Manager, you set the priority on what queries are, high priority queries and rank them. And Redshift ensures that you're not managing, memory space and trying to fight for resources on the cluster. Excuse me, just a second, drink water. There's again, Ryan touched on this earlier. There's some advanced monitoring that's also looking at when to do auto vacuums, when to do an auto analyze, or when should we do a table sort. So all that said and done, you can still take over and fly in the weeds and take control of it yourself. I find that most people, it's a mix, but more and more of these features are just coming out that's making it almost a no-brainer to say, let's take some of this management workload off and let my people innovate. So yeah, let's go a little further into the architecture here. And with this, you may hear some repeat information, but I truly hope that as we go further and deeper, it builds on itself. So Oops, excuse me. So what is the Redshift service? Again, it's it's a service where you can start with gigabytes of data, hundreds of gigabytes of data, and you evolve that and scale that up to exabytes. It's fully managed, it's fast, massively parallel, and taking care with the RA3s and moving the data closer to the compute with Aqua. It just seems to get faster. It's highly resilient, with an SLA of 99.9, secure, all your popular compliances, all your major compliances, not popular, but major. It adheres to, options for encryption and, SSO. So, very flexible in that regard. And I'll go back to the, earlier statement, gigabytes to exabytes, with several auto scaling methods in place, and it integrates with many of the data sources, including your data lake. It's Redshift is a columnar data store. It stores its data in columns. And for those not familiar with that, what that's really buying you is when your query runs, it has to scan a lot less data to bring that query back, and obviously thus increasing the performance, the speed of the query, and the cost savings, because within this data lake architecture that we're looking at here today, some of the services, and Ryan brought this up with Spectrum, if your data is not partitioned correctly, and these kind of scans can cost a lot of money. And just a little bit of the technical background there. There's the columns are one megabyte immutable data blocks, and those blocks are encoded and automatically encoded with one of 13 different encodings. And you can have multiple encodings within your table. No, what's under the hood? As Ryan said, when Redshift was introduced back around 2013, I think, it was built on Postgres SQL, but on that engine. But in those 7, 8, 9 years in the interim, things that it doesn't really resemble Postgres anymore. A lot has changed in that regard. So when somebody comes and says, "Well, that's just Postgres," you can confidently say, "Well, no, it's not. Not by a long shot." And also, again, we're talking about seamless integration with the data lake. We have, we spoke to some instance types earlier. We've spoken a lot about RA3, but there's the DC, the dense compute, and the DS, dense storage, that still play an integral role. And it's really a use case kind of thing, where you can really get some economies of scale with RA3. One is in streaming data. If you're going to be streaming data to your Redshift cluster, RA3 is really going to help you there, because you're not having to continuously scale the storage. But DC and DS compute nodes are excellent in a lot of use case situations. And so just here some statistics, I guess, on the node types. Price, performance, and scale. We talked about concurrency scaling a little earlier. But just to touch on it again, it basically give you unlimited scalability. It's often said within AWS parlance that S3 is virtually unlimited. Well, the same can be said here. And again, back to the 1 hour operational or 24 hours operational Redshift cluster buys you 1 free hour every 24 hours. That was kind of a long way to say that. Just basically touching on here, back to the pause and resume the auto workload manager, back to prioritizing the queue automatically, and the cross zone replication, which is a great with cross zone replication with auto failover and the auto snapshots that AWS is taking at a cadence, which, if memory serves me, is like every 5 gigs ingested or every 8 hours. But somebody could check me on that. I think that's what it is. So, yeah, moving on. Let's go to the next section. Data warehouse migration, process, and journey. So just, Ryan, are there any questions? Let me take a sip of water and see if there's any questions in there.
So I haven't seen any new questions in either the chat or in the questions area. So okay. I think we keep moving forward.
Okay. So, oops. What to expect during the migration journey? So, moving to this architecture, obviously presents challenges, and that's one of the things that Mission as a partner, an AWS Premier partner, can really help you with. We have I don't know how many at this point, but over 100 certified AWS certified people on board, and one of our competencies is migrations, one of our AWS competencies. And so we can support that at any scale, from a startup POC, MVP environment, all the way up to, a massive, multi-petabyte migration. So the 3 steps in the process. There's the analyze and plan, the workshop and pilot, and then the actual workload migration itself. And so what you do is you start with the analyze and plan, where Mission's going to work with you, to discover in deep discovery sessions and planning sessions, depending on the complexity. This can be a several-week process, and it's done with the data consultants like myself and my data engineer colleagues. We help build a business case for the stakeholders in that process. Look at what the end, define what the end result of the migration is going to look like, and overall, plan this from soup to nuts and then carry it out. So the workshop and pilot piece, there are a number of tools here that we employ, and we're definitely going to touch on these in more depth a little later with the schema conversion tool, referred to as SCT. We'll hear a lot more about that later. And then the data migration service, which is another valuable tool in the toolbox. And so we come in at this stage and we're looking to design that POC POV, and architect it and build it. And you know, we also help in the process of modifying and designing the the downstream tooling, the applications, the BI tools that this new architecture, how users are going to interact with it and bring value to this data, along with connecting this with things like SageMaker and EMR. And then so we help the customer understand that, and also we understand that there's a good, in a lot of cases, there's a good deal of knowledge transfer. So Mission works with you in that knowledge transfer. We also, we're not a training organization per se, but we can certainly point you to those resources. So then the migration phase, well, that's when all the magic happens, and we build it out, and we really, at this point, once it's in prod or operational, we're now looking to layer on that with some more optimization throughout the entire pipeline. As we know, Redshift is handling a lot of that automation, and so we can backfill and really concentrate on other components in the architecture. So this is migration pattern in terms of working backwards. We got to do some validations and testing and all this good stuff along the way before we can power off the legacy system. And in order to accomplish this, stakeholder sign-off is going to be critical to that. So that's where we're starting in this journey. But you can also look at that in terms of the end user or the end application and working backwards from there. But we're going to provide a functional audit. Let's compare the two systems as it exists, both the old and the newly architected. At a feature level, let's look at some comparisons between SLAs and performance across the systems. The next phase of that is let's sync up our deltas. How are we gonna? We've got some historical data or a bulk ingestion of our data, but now we've got to start ingesting that data so that we're capturing our changes at whatever cadence that may be. And then we need to validate that CDC logic. And a great place to do that is within lake formation in S3, because you have governed tables, and governed tables, that's what they're designed for. So this is sort of a holistic approach to the process before we go live. And this slide really goes to pretty much any migration. You got to look at your schema and your data transformations. You got to convert some code, ETL scripts, SQL. You need to migrate your data. So here's what we're saying here. Part of Mission's job is to map data types and choose our compression. Although we've said that our sort keys and distributions are auto, still somebody needs to look at that and come up with a game plan around that, and then apply the DDL. What are we going to do with our existing code and existing ETL scripts, and then migrate the data in bulk, and then, as we said, sorry. But and there's also AWS has a lot of tooling, and that's so don't get scared off at this point. AWS, and there's a lot of AWS certified ISV third parties that have a lot of tools, great tools around helping us achieve this. A little touchy there. Got ahead of myself. So we mentioned a few slides back, schema conversion tool. This is a lifesaver. So what we're going to do is with schema conversion tool is it's going to look at your source and your target, and it knows within a margin of error, let's say 10 to the outside 15%, well, it can automatically convert what I'm trying to say. Let's just say, for argument's sake, about 90% of your code, your triggers, your indexes, your stored procedures, logic, and so forth. But it's looking at the source and target. It knows a lot in between, to say that's a quicker way of saying that. It knows a lot of how those two are going to talk to one another, and then it performs some schema optimization from the source to the target, and gives you some very detailed reporting on that we're going to see here in a few minutes, and even as an agent that will help you do extraction, and we'll compare two different services, the agent versus the DMS shortly. Okay, so here's an example of the report. And this is, highly recommended first place to start. Is the migration assessment report. And I can assure you it's going to make all of our lives easier going forward. So it's going to indicate supported and unsupported code. For example, Redshift does not support sequences. It's going to provide some licensing information on the source system. It's going to break out the level of complexity from easy to complex in terms of what mitigation needs to be taking place. And in the end, it's going to give you some very, very detailed corrective action. So as I said, there's some things going on in the middle between the source and the target that SCT knows about. So this is part of machine learning and at scale, and a lot of customers coming to AWS and making these requests. So this is, you need to keep up to date with this particular tool because it's changing very rapidly. Not the tool itself, but its capabilities, I should say. So here are the components in the screenshot of the tool. And on the right-hand side, you've got the source schema. On the left-hand side, number 3, you've got the target schema. In the middle with number 2, you've got that ranking that's telling us if it's complex, easy, whatever the scale was. And then in number 4, that's giving you properties, looking at the properties of this specific find. And finally on number 5, that's giving you converted code. So it's very powerful. Excuse me. So yeah, that code is, number 5 is automatically generated, and that's where we're looking, at real efficiency gains. So this is just a screenshot of an Oracle to Redshift, and you can see on the top, it's looking at the DDL there, and it's making that conversion on the bottom with encoding and, you know, making the conversion on the data type and the encoding amongst other things. Interesting. These extension packs to the SCT. So what that does is, you know, many times you try to emulate the behavior in the source that's not supported in the target. And you know, the great thing about these extension packs is they create those functions automatically in the target. And that's not to say that 100% of this would be converted, but a very large percentage will be. So, you know, you can look there where it says the, you know, Microsoft SQL Server. One way to quickly identify this code is its naming convention. So that's just, you know, a time saver in that regard. And then there's some other resources, you know, per this link, and everyone will be getting these slides shortly after the call. And, you know, so again, we're back to saying we may need to modify some of our code, but most of the heavy lifting is being done by the tool and these extension packs. And this is just simply part of that extension pack that's looking at Teradata. It's looking at the function and it's converting it to Python code. Just quickly, take a moment to look at that while I wet my whistle. Again, we're just looking at the same kind of thing with that Tisa function and the Python code generated by the extension. ETL migration, always a hot topic with most customers we talk to. So with ETL migration, you know, we're able to integrate with a lot of third-party tools. And you know, modernize the pipeline by integrating with you know, the Informaticas of the world, the Talents, also. But in addition to that, you know, some of your BI tools like Tableau and Power BI have ETL functionality as well. So it's able to integrate there. So if you're looking to migrate, and it's also if you're looking to migrate off of your, you know, your Informatica, your Matillion, your Talent, you know, that's certainly in the cards. So AWS can copy and convert right now. Let's say this probably change, you know, here shortly. But at this point, the copy command, the AWS copy command, can convert Oracle and Talent scripts to glue jobs, you know, on the fly. Not the only options that our team is exposed to, and we'd be happy to, you know, discuss your ETL pipelines, what's giving you heartburn in those pipelines in terms of your migration process. And you know, there are a lot of third-party ISVs in the ecosystem as well. So let's look at the schema conversion to you know, the best practices of a migration. So highly recommended, as we go back several slides, to run the migration assessment report. And lean on it heavily. The majority of your DDL and SQL can be migrated using the SCT and the extensions packs. history has shown us that's in the 90% range. So it's going to vary, obviously. And those, also, a while back, it was a knock at stored procedures, but now you can migrate your stored procedures. Take advantage of the materialized views to migrate these complex queries for your BI dashboarding to get better performance out of them. Remember, you don't have to migrate all your data and store it on the cluster. There's plenty of options here, and it's easy enough to move data from the cluster to Redshift with a create external table command, and put that data into S3, offload it from the cluster, gain some cost savings. Again, it goes a lot to how you're partitioning your data and querying the data, but you're going to see some cost and very, very little, if any, performance degradation. So a number of partner tools in the ecosystem can be found at the link below. I just call out that the Next Pathway does a good job of scanning pipelines and scanning the environment, the current environment, and being able to convert that to compatible code. And obviously, Mission is here to support you in your process of identifying tools best suited for your use case. So let's take a look at the data migration toolkit. So there's just quite a number of ways to get your data into AWS and into the modern data lake architecture. So let's just jump on we talked a little bit about. Let me jump ahead of myself. So you can use the S3 API. Just to call the API and ingest your data directly that route. You can enable the transfer accelerator and get up to 300 times faster uploads over that service with accelerator enabled. There's the transfer family, and really what that is a managed FTP essentially. And you don't have to manage any of that, and it allows you to get small files into AWS. There's data sync, and it can be used for a whole migration, and it does perform CDC, and it's pretty darn fast. So it's certainly in the toolkit. For customers moving lots of data back and forth between on-prem or their hosted environment, you're going to look at direct connect, a high bandwidth, low latency connection between your data center and AWS. Then there's the Kinesis family of products, but what they're going to do is allow you to ingest data in real time or near real time or whatever cadence the job calls for. There's also Storage Gateway, and Storage Gateway, is an appliance that is essentially running in your data center that is providing a shared file system There's multiple versions of this. You can have volumes, you can have files, but essentially what they're doing is they're syncing your data center to the cloud. There are a couple different options you can go with there. Cloud Endure is a disaster recovery. Just helps you replicate existing servers, VMs into the cloud from a disaster recovery standpoint. And I guess we'll move into talk a little bit more about database migration service as we move forward here. Oh, here we go. Perfect. So, what is the database migration service? This is a service that helps customers migrate their databases to the AWS cloud quickly and securely with zero downtime. The service, interesting fact, the service is free for the first 6 months. Get all your data in 6 months, it's for free. And at Mission, we use this service quite extensively. And we touched on the extractor, the schema conversion tool, data extractor a little earlier, I believe. And what you're looking here is just you're installing an agent, and that agent can go on really any computer with a connection, but you want to get as close to the data as you can, simply put. And what's going on here is you definitely want to run multiple agents in parallel, and we'll see some of the efficiencies gained here shortly. But great way to get your data into AWS. And so, here are the comparisons between the DMS versus the SCT. A lot of sources, source data with source databases with the DMS. It'll do a full load. It'll handle CDC where extractors will not. So you can maybe use them in combination. Depending on the workload. Have SCT extractors, well, one of the things that with SCT is extractors are more configurable, right? So, you do your bulk load with SCT, and then you bring in DMS to now start with the CDC captures. One is a managed service, one is not. And so here, what you're looking at is just a visual comparison of this. So if you're on the far right over there, and you're in the Teradata world and the TISA world, SCT is your way to go. If you're in the Postgres or the MySQL or the Mongo or the DB2 world, DMS is likely your best answer. Where it gets a little, tricky, you have to ask yourself some questions, is with Oracle and SQL Server. And really, if you have many terabytes, you're looking at the extractor. So let's dig into the agent a little deeper, understand how it gains this efficiencies. So the key feature of the agent is it's multi-threaded, and it can move large amounts of data in a single job with multiple agents. Great feature. If a job fails, it's bookmarked it can restart the job, and you're not going to have to go back and restart the whole thing over again. So, So how does it work? It supports a full copy of your system data, and it does that by using, as mentioned previously, multi-threads to parallelize the extract, the upload, and the copy. It can move large amounts of data quickly and securely. And the way it's doing that is it's writing to a local machine, and local machine is very loosely defined here. It can be EC2, it could be, something in your data center, but what you're trying to do here is essentially right size that. But in the process, what it's doing is saying it's extracting that data, it's compressing that data, and then it's copying that data to S3, and then once it arrives in S3, it can automatically load it. It triggers a load, an S3 trigger to do a copy of the data to Redshift. You can from a security standpoint, SSL, data in transit, and then with very large tables, you can partition. You can virtually partition the data with the tool. It's pretty much simple. You create a task. You set that task to run in 3 different ways. You can tell it to extract the local, which is the one running the agent. You can say extract to S3, or you can tell it extract, upload to S3, and copy to Redshift. You hit the test button, all successful there. You hit the go button, and you're off and running. So what are some of the best practices with the extractor? One, as I mentioned earlier, install it as close to the data as possible. Right size the instance, EC2 or local, however you want to define instance. Obviously, the multi-agents, and sort of the rule of thumb there is 1 agent per terabyte of compressed data. You want to take it offline. You want to get pretty much a standard rule of thumb in something like this is you want to run it in off peak. So anything. There's a decision when you get into the hundreds of terabytes of data, and the AWS Snow family can really help with that. And those are appliances that you order from AWS. They're shipped to you securely. Everything is encrypted. You plug it into your network over some very high-speed connections, and put the data on there, securely ship it back, and AWS loads it. So when you start getting into at the low end of the terabyte scale, in the hundreds of terabytes, you might want to start looking at Snowball, or if the option is available to you for a direct connection, you can direct connect or will suffice for sure. But when you start getting up into the high end of the terabyte range, you really start needing to look at the Snowball family. So I had some others. I guess we have a little bit of time, and if Brian or anyone, you want to keep going, we can sort of take a high-level look, leave a little bit of time at the end for some questions.
Yeah, I don't see any question, or I guess there's some more questions, Scott, if you look. How easy the SQL portability from other databases to Redshift? So how easy is it to port your SQL code from So that's a good question. One thing you have to look at is how optimized you made your SQL, right? Oracle has a ton of special SQL calls and all that, and so that can be kind of painful to port over, but most other instances, it's fairly easy.
Yeah, and a lot of the schema conversion tool is taking care of that.
Right. And then another question for you, Scott. They currently use a lot of partition tables. It looks like there's no partitions in Redshift. How do you handle this?
Partitioning in Redshift, I mean, we're loading our data, we're distributing the data, you know, on distribution keys. So that's one level of partition. And partitioning it, you know, in terms of the sort keys and arrangement of sort keys on slices, and you know, that's a partitioning.
So Ramesh, if you have a little bit more of a question past what Scott suggested with the partition or with the sort keys and whatnot, you know, please post that in chat and we can get an answer. Does Redshift inherently favor ETL over ELT?
You know, that's a great question. That's a use case question. In my experience, I'm gonna say ELT, but I'm seeing a lot more people moving to ELT. I had to get my acronym straight. I'm seeing quite a bit more people look at it that way.
Yeah, some of that's just
that's just in my experience. I'm maybe a little biased, I would say, in that regard.
Some of that's really depending on the tool, right?
Yeah.
So I know like Fivetran and Upsolver and some of these other tools are talking more about ETL and instead of ELT. So, you know, it really comes down to which kind of tooling you're using. But from my experience, it doesn't, you know, Redshift can work with either of these flavors of how you want to set your data pipeline up.
Okay.
Yeah, so Scott, that looks like all the questions right now. It looks like
okay.
you answered the meshes, so we can go through some of these additional tools.
Okay. Well, we've seen this before, but we're just looking, you know, at these that have already been mentioned. But you know, just sort of high-level architectural diagram here. So, you know, with the SFTP, FTP, FTPS, etc., that's part of the transfer family. Again, it's managing that. It's managing those services, so you don't have to. And you know, you're bringing it in, you're putting it in your data lake, preferably lake formation, and you know, now it's available to downstream. Data sync, we talked about that with file systems and edge devices and something called Outpost, which we won't get to today. And you know, we're ingesting these, and we got the CDC factor here going too. Direct Connect, you know, I think most people will be familiar with a high-speed, low-latency connection. So nothing exciting. The Snow family, this is, you know, as we start to see here, you can look at the capacity. So at 8 terabytes is you know, 80, and then less than 100 petabytes. You're going to get the big tractor trailer rolling up on you. But so we talked about that. You know, at the low end with the snow cone, you got Wi-Fi. You got some. You can also have some compute on the end of that with IoT at the edge, with Greengrass and a few some flavors of the EC2 AMIs, and you can cluster them. Okay, timeline. This is a good one. With the Snow family. So you create the job. This is how the process works. They ship it to you in a couple of days, n number of days for you to load it, 1 or 2 days for it to get back, and in number of days to secure it. Job complete. It's swiped. Storage gateway. Forgot that this has several things. You see the different flavors of that. You got the file, which is file-based application. You got the SAN, and then you've got it can act as a tape backup as well. But that's essentially how it's working. And you can cache files here in both directions. Cloud Endure. Automated tool, so a good shift, a good lift and shift could be used in the Cloud Endure. So as you're backing up your servers, or you're replicating your servers, not necessarily backing them up, you're replicating them. And this is some CDC best practices. We won't get into that this afternoon, but excuse me. That's about it as far as my slide deck goes. And I've been talking too much.
Okay, awesome. Thanks everyone for attending. There's a couple of poll questions here at the end. The first one: are you working on projects to migrate the customer data warehouse to Amazon Redshift? Let's see, it looks like most people are not working on any kind of migrations right now, which is, I think the next one asks if you are going to be doing, I guess this one has in the future. So there's about, I'll give it 20 more seconds and then we'll close the poll here. All right, cool. So I'm going to close that one, and that looks like all. So I don't know if anyone has any additional questions or not. If not, thank you for attending. We'll wait, another couple of minutes to see if there's any additional questions. But appreciate everyone's time today learning about Redshift and how to think about it and use it in your migration strategy.
Likewise, thank you everyone. Enjoyed it and would love to talk to you about your specific use case. Have a great rest of your day.